Hey everyone, Scott here from Southwest Michigan System Center User Group. Going to go step by step through the entire process to deploy the IGEL Universal Desktop onto devices both through bare metal builds as well as in-place upgrades onto an existing Windows OS. Here you see I'm using the Microsoft 365 Modern Deployment Lab Kit. I have a pre-configured VM with the base IGEL image on it with no other configuration. This is the machine that we'll be using to capture the image for the deployment through Configuration Manager. As you can see, there's no additional configurations here. Let's go ahead and shut this VM down. And we'll jump over into the Configuration Manager VM. In Configuration Manager, we're going to go ahead and get started. We're going to work with our boot images first. As you can see, it's just a out-of-the-box Configuration Manager build through the Modern Desktop Lab Kit through Microsoft 365. A couple extra devices that we're going to use for in-place upgrades later on down the way here. But as of right now, let's go ahead and create a couple folders in the root of the C drive. We'll call the first one source, and then the next one we will just call mount. And these are going to be the folders we're going to use for using the DISM tool to modify our boot image. So let's grab that boot image. We're going to use the default location for the Microsoft ADK. We are using version 1803. So you'll see program files x86, Windows Kits 10, assessment and deployment kit, Windows pre-installation environment, x86, English, US, winpe.wim. Let's copy that, and we're going to paste it over into our C source folder. This will be, we copied it there so we don't make any changes to the default install from ADK. So within Windows Kits here in the start menu, let's launch Deployment and Imaging Tools as administrator. And here we're going to use the DISM tool to inject an application and a DLL into our boot image. The application is called DD for DOS, and this tool is going to allow us to capture and write the Linux image onto our disk. So let's run dism mount-wim. Wim file is c source winpe.wim. That's the file we just copied over. Index 1. Mount directory will be c mount. Let's go ahead and let that go. Okay, we see the operation completed successfully. Let's go ahead and take a look in our mount directory. And here you see the folder structure of what was inside that WIM image. And here we're going to go to Windows System 32, and we're going to place the DD for DOS that we downloaded into the System 32 folder. Here's the location where I downloaded it from. There are other versions on the internet. This is just the one that was on one of the guides that I was using to create these instructions. I've already downloaded that, and I have it on my config-man VM in a folder called DD for DOS. Let's copy both the DLL and DD executable and paste them into the System 32 folder. We will have to provide additional administrator permissions here. Do it for both. Continue. Those copied over. They're both there. Make sure you close this window out before we go back to unmount the WIM, otherwise it will fail. So we call up DISM again, and instead of mounting, of course, now we are going to unmount the WIM. And the mount directory is cmount. And of course, we want to keep the changes we made, so we're going to do a / commit and hit enter, and then let it package that back up into the WIM file. Okay, the operation has completed successfully. So now we should have a newly created WIM of the winpe.wim, which is just the base boot image now with DD and the DLL. So we will copy that over to our configuration manager source folder. I have one here just called sources boot images. We'll paste that there, and that is on the config-man VM within the lab. So we will go over to configuration manager now and add a new boot image. And let's point it to that WIM image we just created. And let's name it boot image with DD. We are using ADK 1803, so I'll just throw version 1803. And this takes a minute, so we'll jump forward here. Go ahead and take a break if you need one. All right, a few minutes later, we are here. So we'll go ahead and close out of this. Now we have to make a couple changes here before we're ready to distribute this out. So go to properties. And first thing we want to do is we want to go to customization and add F8 support. So check the enable command support. And we also want to go to data source and enable this for Pixie deployments if you will be using this in Pixie. In the lab, we won't be using it, but make sure you check this if you expect to be able to do this through Pixie environment. So check that. We'll apply the changes. And a few more minutes again. Okay, now we've got that all squared away here. We will continue. We'll want to distribute this to the distribution point in Configuration Manager. In the lab, we only have one distribution point, so we will go there. All right. Now what we need to do is we need to create a boot image. Since we're not going to be using Pixie here, we're just going to create task sequence media and then bootable media. We're going to leave this dynamic media. We're going to point this to the ISO location that we want to create. And we're just going to put it right back in that sources boot images. And we'll call this SCCM with DD. That'll be .iso. Save that. And for the test, we don't need a password on this. We'll leave the rest default. And boot image, we want to make sure that we use the boot image with DD. Again, only one distribution point, as well as one management point. And we are ready to create the boot image. Just take the defaults the rest of the way through here. Next, next. Yes, and let it go. Okay, we have now created boot media to boot into the SCCM environment, and we will be booting our device. The IGEL image that we showed earlier, the base configuration, will boot that to this boot image to boot into SCCM with the DD boot image, and we will capture our image. So I'm going to copy this boot image over to the host machine so I can attach it to the virtual DVD drive on the Hyper-V. IGEL 1. So we will go ahead and attach the ISO we just created. So we can boot to SCCM with dd.iso. To get us into the SCCM, you'll see here there are 2 hard drives attached. The IGEL 1 attached to IDE 0 is the operating system, and then here you'll see there's a hard drive called images. And that is the hard drive that we will be writing to when we capture the operating system image. So let's go ahead and boot to the SCCM environment. Now we're not going to actually want to proceed through, and we don't even have a task sequence to choose from here, but we just want to hit F8 so we can pull up a command prompt. And here you'll see I have commands that we use for DD, but first let's make sure we know which volume we are going to be writing to. So let's open disk part and list the volumes. So we'll see the 80 gigabyte volume letter I is our 80 gig images virtual hard drive I showed you a minute ago. So let's go to DD space hyphen list, and you'll see that it does give us quite a bit of information about the attached drives to this virtual machine. We're interested down here to the block device objects, most notably the hard disk 0 and hard disk 1. You'll see hard disk 1 partition 0, that is the only listing there. That means partition 0 is the entire disk. As you'll see above, we have partition 3, partition 2, partition 1, as well as hard disk 0 partition 0, which would be the entire disk. So there are 3 partitions on disk 0. So disk 0 is the OS disk. So let's go ahead and capture that. So DD input file equals, as you see the format is \\, device, hard disk 0, partition 0. We're going to grab the entire disk. Space output file. Now we're going to use the I drive, which we determined from disk part that is what, yep, here we go. I drive, igel.img, block size equals 1 meg, -- size, -- progress, and now we're okay to capture this image. You'll see the input format is hard disk 0 partition 0, but the output format is actually the volume that we got. So let's let this run. Takes a minute. Okay, now we have captured the image. I did speed that up a little bit if you watched the block size count up. So as you see, the directory of the iDrive now shows igel.image. So we can go ahead and close out of IGEL 1. We're done with this. Now let's I'll copy over the igel.image from that hard drive onto the config-man server. Okay, now we're at config-man, and you'll see that in the OS images I now have the igel.img, and I'm gonna also place this diskpart.txt in that same folder. You'll see it's very simple. Select disk 0, clean, and exit. That is all we have to do. So now you'll see they'll both live in the same file there, and we'll get to that here in just a moment. All right, so what we need to do is we need to create a task sequence to image a device. So create a new custom task sequence, and we'll call this IGEL build. We want to choose the boot image, of course, with DD. And next. And let's edit the task sequence with the steps to image a new device with IGEL. So first thing we need to do is we need to connect a network folder. So we'll just call it connect to configman1. The path is CM1 sources OS images is where we place the igel.img as well as the diskpart.txt. So let's point it to that folder, and we'll just call it the iDrive, and we will of course connect to that with an account that has permissions. So the lab admin domain admin account here in the build lab, punch in the password. Let's verify that we have that connection okay. All right, so now we need, the next step is we have to prepare our disk using diskpart. So let's add a command line, and we'll just say prepare disk. And of course, diskpart is part of the boot image, and we have our diskpart script in the iDrive now because the step before it we connected to it and called it the iDrive. So diskpart/script I diskpart.txt. And that is all we need there. And of course, one more step here, run command line, and we're going to call this apply IGEL image. So this command is going to be nearly the identical one of the last time, just reversed. So now the input format will be the iDrive, igel.image, and the output file will be \\device /hard disk 0 /partition 0. We're going to do block size 1 meg again, space -- size space -- progress. And that is all we have to do to apply this to a new device. 3-step task sequence. Pretty slick. So we create another one for Inplace upgrades. So let's just copy this since the steps are almost exactly the same. Now let's go to properties so we can rename it. IGEL, we'll call it conversion. And punch over to the advanced tab, just make sure, yes, we're using boot image with DD. Okay, good to go. Let's jump in the edit here and add one step. And this, since it's going to be an Inplace upgrade, we're going to start in the operating system. So let's add a restart computer and choose the boot image assigned to this task sequence, uncheck notify just to speed things up. And we want to make sure that is the first step in the task sequence. Apply, okay. And we have 2 task sequences, very simple. And let's deploy these. The IGEL conversion, I've created already a device collection called IGEL conversion. We'll deploy this here. As available, and only configuration manager clients is fine since this is going to be used for upgrading current clients. And we'll take the defaults the rest of the way through. And now let's deploy the build. And this one will be going to our unknown computers. So this needs to go to more than just that. So we're going to include media in Pixie and defaults the rest of the way through. now we're ready to build. Let's close this. Let's launch IGEL 2. Connect. We'll go ahead and start this. I'll show you. There's no operating system on this right now. It's just a blank hard drive. So as we sit here, we have nothing. So let's attach the SCCM boot media to this. SCCM with DD. Start it and boot into the SCCM boot environment. And we should now see an available option under task sequences here of IGEL build. And there it is. So we'll choose that, say next, and I'm going to let this roll without jumping forward just so you can get an idea of how fast this imaging process is. For the sake of time, when I do the Inplace upgrades later, I will skip through the apply IGEL image, but I'm going to let it go this time just so you can see how long it takes to do this process. Okay, that step has completed and it's restarting now. And we'll let it reboot. And as you can see here, we are loading into the IGEL Universal Desktop. And I moved both of these to the device collection, IGEL conversion. There we have it. Okay, now let's go ahead and move forward with an Inplace upgrade. Here you'll see our Windows 7 device. Just a base install here, really, of Windows 7. We'll go ahead and launch the Configuration Manager control panel. And we will launch Software Center. Okay. The operating systems, you'll see there's nothing there. Let's go ahead and run machine policy retrieval and evaluation, and it should pop up momentarily. And there we have operating system 1, so let's go there. Refresh, there we go. IGEL conversion. Install. And of course, our first step is to restart the computer, so it has to download the boot image since that's going to be booting into there before completing the task sequence, which was identical to what system we just did. So I'm going to jump forward here after this boots in and starts to apply the image. As you could tell before, it took about a minute. I would say between 1 and 2 minutes is about average for applying these operating systems through DD in the boot environment. I'll just show here before I skip forward that it loads up into the boot image. And once everything's initialized, it will prepare the disk using disk part and apply the image. Okay, now the image has been applied and it's restarting. And our Windows 7 device has now been Inplace upgrade to the IGEL Universal Desktop. And of course, just the base install that we had captured from the IGEL 1 is now on Win 7. Let's go ahead and shut this down and upgrade our Windows 10 device. Same process, just going from a different operating system to IGEL Universal Desktop. All right, I got my Windows 10 device booted up here. Let's go ahead and log into it. I'll show that the device collection IGEL conversion does in fact include the Windows 10 computer. So just like we did with Windows 7, control panel. Of course, this isn't a necessary step, but it speeds things up a little bit. Run the machine policy, and we'll go ahead and launch Software Center. And it's already there as I ran it first this time. So let's go ahead and install. Same process as Windows 7. Everything from here on out should look exactly the same. I will skip through on this, applying the image as well, just to save a couple minutes. But that is the process. Not a whole lot to it, really. Just have to make sure you get DD into your boot image. Of course, in the demonstration here, we used the default one out of the ADK install. You can easily slip it into the one you're currently using in your configuration manager environment. It doesn't add a lot of size to your boot image, so you shouldn't have to worry about that. Outside of the lab, in our live environment, we have upgraded hardware devices in the field to IGEL from Windows 7. It works the same as this. Okay, it's applying the IGEL image here. We're going to go ahead and speed it forward. It's restarting. And it will boot into the IGEL Universal Desktop. Of course, I cut out a couple minutes there, but it is very fast. I'll show here that just the base install of IGEL that we had from IGEL 1. And that's a wrap. We'll go ahead and shut this down. Pop up the notepad here that I have the information that I've used. That's about it.